All right, we are the NDSU Capstone team working for Integrity Windows. I am Chase.
Andrew.
Chris. Jimmy.
All right, and this will be the outline for our presentation. So a quick overview of Integrity Windows, first starting with their mission statement. So Integrity leverages its revolutionary Ultrex fiberglass material to provide the right products and options to its targeted segments that deliver reliable, competitive performance, durability, and value. Integrity is also a service champion in delivery, ease of interaction, and customer satisfaction. But mission statements don't always really tell about the company itself, so here is a little bit more information about Integrity. Surprisingly enough, it's a window manufacturing company. They're also a child company of a larger corporation called Marvin Windows and Doors. Marvin's has around 5,000 employees around the United States. Their website told me they have 10 different locations, but Glassdoor told me 12, so I'm not exactly sure, but it's between 10 and 12, and it doesn't really matter for this presentation anyway. Now to go over the batch file system overview. This is not to be confused with computer batch files, as this relates to batch production in like manufacturing companies. Batch production is a manufacturing technique where the objects produced are created in stages over a series of workstations. With Integrity specifically, a batch is a group of files produced from an order. And these batch files hold information regarding parts of Windows that aid in the production of these windows. So the batch file system is used to generate data for machines or like the production workstations. And we're a little bit unfamiliar with this because we haven't toured the plant, and I haven't been to a Marvin since like a second grade field trip or something. So anyway, now to the actual problem. Data must be entered into their database and matched with incoming batch files data. To do this, they currently use Batch Integration Optimization System and Microsoft Excel to enter and upload data into the batch file system. But this can cause problems, especially with manual data entry and data verification. At its longest, it can take a week to verify data. And manual data entry itself is time-consuming, tedious, and just inconvenient. This is what the current BIOS system looks like. And like all computer science people, they thought, you know what, there must be an easier and more efficient way to do this. So that's where our Capstone team comes into play. Our solution, well, they need a robust solution to fix the manual data entry problem and the data verification problem. So this is what we've come up with. A web-based application that can edit data in the database, add new parts to the database, and can verify data. Now, some of the objectives for our project. Well, we need to make it a spreadsheet-like interface for data that has the intuitive functions, you know, like being able to copy and paste large amounts of data into and out of the spreadsheet, sorting the data by columns, quickly inserting large amounts of data into the spreadsheet, and having a built-in version control software similar to GitHub. So like if anything detrimental happens, we can go back to a different version, and this should also allow different users to have like their own branch where they can like push their changes and have the system developers accept these changes. To accommodate these objectives, these are what our user stories are, and we have two users. We have the process engineers and the system developers. The process engineers are the ones really adding new data to the database, while the system developers are in charge of monitoring and maintaining the system as a whole. So these are some user stories that we have completed. As an engineer or system developer, I want to be able to see current parts that are stored in a database on the web interface. You know, this one's pretty entry level. Basically, you want to see the current parts that are in the database. As an engineer, I want to be able to modify data within the database using the web interface, but only for certain tables. We were told that the engineers really only need to edit 4 of the tables, and there's like 19 or so actual tables that we are working with. And as a system developer, I want to be able to modify the data within the database using the web interface. This one's pretty similar to the engineers, but the systems developers should be able to do it for all of the tables. Now, these are the most prominent user stories that we have to complete. As a systems developer, I should be able to verify part information before it gets to production. The systems developers should be able to see like what parts are compatible and then verify them before production begins. As an engineer, I want to add multiple similar new batch files so that new products can be created. This consists of selecting multiple cells and being able to put all the same information in them at the same time, and also like copying and pasting rows to other rows. And for the last one, as a systems developer, I want to see unsubmitted changes to the database so I can answer engineer questions. Basically, the engineers will be working on like their own separate table, and the engineers want to be able to, or the systems developers want to be able to go in there and see the unsubmitted changes, so if the engineers have questions, they can answer those questions. And this is our schedule that we've been working with so far. Sprint 1 was really familiarizing ourselves with the languages, as we weren't that familiar with them in the first place. Sprint 2 was the functionality for one table. Sprint 3 is like the remaining table functionality and starting the data verification side of things, while Sprint 4 is data verification and multiple copies of databases. And now I'll hand it off to Andrew, who will be talking about like the use case diagram and really the implementation of our project as a whole.
Thank you. So I'll be talking about kind of the overview of how we plan on implementing or solving the problems. So as Chase said, we have two main users, the process engineers and system developers. One of the main functionalities is going to be viewing the tables. And with viewing the tables, we want to be able to hide certain columns to make the tables more readable, and also sort the tables based on columns if they're looking at need to find particular information. And then with that, they want to be able to edit the tables. So engineers have 4 separate tables that they will be focusing on, while those other tables the system developers will have access to that kind of run on the back end to support those engineer tables. And then as system developers too, they'll be applying the changes that the engineers are making, and if the engineers having questions, kind of view those changes and help them out. All right. So here's kind of a simple diagram for one of the tables, the profile part map. There's also a call size map, machine part map, and stock size cut down that the engineers will have access to and be able to edit. So here's a breakdown of kind of the task diagram. For the rendering of the website. So first we connect with the database, create a Redux store for the information. All of that data is put into a table component, and each field from the table is entered into an array, which is put and then rendered onto the page. Okay. For editing, very similar. It takes the copy of the database, the engineers will edit, and then the system will verify some of the data to make sure that it is possible and autofill some columns that are can be derived based on previous entries. The engineers will kind of submit that to the system developers to get approval, and then the system developers can commit those changes to the main database, or else they can decline it and have those tables be deleted or go back for editing later. So here's kind of an image on our version control. So each process engineer is going to have access to a copy of the database where they can edit. So while they're editing, they aren't going to be using the main database and causing issues with that. The system developers will then be able to see all those copies and also have access to the main database. Okay, so I'm going to hand it over to Chris, and he'll show a short little demo about of what we've done so far.
Right, so here's a little more like technical overview of how the data is flowing in our app. So it starts in the database, and then we have API endpoints that will connect to our database to get the data, and then we store the data on the front side in the Redux store, and then we have container components that connect that data to like the tables that we actually render. So kind of the main takeaway is how it's circular, and then the data that's being rendered when you update it gets pushed to the database and so forth. So it's very circular. And here's kind of a mock-up of our UI. So like these tables will be under the batch file management system here. So those are like the 4 main engineering tables. So that's kind of the focus of it. And then like parts list will be like the other tables that aren't as important. And then it'll sync and save are kind of the main things. So sync will get the data that's currently in the database. So if somebody else like made a change to the table, you could pull those changes to see them. And then save will push like what you changed to the database. And then for the system developers, which requires you to log in, they have little extra features. So they'd be able to like view the tables of the engineers, and then they'd also be able to view the change logs so that they can see what they changed to help with like the verification process. Okay, so here is our one main table, and so you can edit multiple cells, and then if you save it, it'll push those changes to the database. So if you sync it, it won't change. And then say you make like a bunch of changes that you don't want to keep, then you could just sync it, and it would go back to what it previously had from the database, and it would also pull changes that other people made. And then our profile part map, so this is like the big table. He showed the diagram. So it connects with like all the other tables basically. So each column essentially maps to a different table. It's like, and then, so we pull the data from that. It's like the part ID. It's like, we actually show the name of it. So if you look at this table, you can see that one is rail. So we're taking the IDs, and then we're taking the names from the other tables, just so that it makes more sense when you're looking at this table, so you can kind of get an overview of all the other tables and whatnot. And then here's like the side navigation bar, which right now is just this one section, which are these main tables. And then Jimmy's going to talk about some issues and risks that we'll have going forward.
As Chris said, my name is Jimmy. I'll be talking about some issues and risk. So far, we didn't face too much issues. We had some little issues at the beginning about learning what's going on and getting familiar with the language. And for a while, we couldn't figure out how to edit multiple cells at the same time. But after Chris and Andrew put some hours in it, we were able to figure it out fairly shortly. And with Ruben, and he mentioned talking about using Blueprint as one of the development tool, and we're still learning what's going on with it, and so it's gonna take a while. But as far as our pace, we should be able to get it done by the end of the semester. And as far as the user story goes, our sprint 2, we came up with 21 user stories. 3, 13, 4, 21. We haven't completed all of it, obviously, but we are still going on our pace, and we're not behind, so we should be able to do the project in time. And more for the reflection side of it, we are having a little issues with getting the face-to-face meetings, since everyone has their different school schedule, work schedule, clubs, whatnot. But I think we're gonna try to do more face-to-face meeting, including the Skype and other form of communication such as Slack. And we're working on more planning for sprint for the end of semester. Even though we're going on our pace and still working on a good pace. We could probably do better at it. And as far as if it gets better, we can probably add some more features that maybe Ruben could think of it or Marvin could think of it. And for our goals for the by end of semester, we're trying to allow multiple cells to enter the database at once, and not only one database, but maybe multiple databases at the same time, and implement autocomplete drop-down for entering data, such as if you're trying to find a material called steel, you just type ST, and then since this steel starts with ST, it'll pop down, and it should be easier to search it and find it. And we're working on the sorting a column or table, so it's easier to sort it by materials or by the size or whatnot. And we're still working on the other tables. Out of those 19 tables, we are working on 4. It's barely working, but there's 15 more on the non-engineer side we can still work on. And with that, we'll take questions.
You're just doing it for the integrity portion, not Marvin,
That's correct.
for the integrity portion. Didn't I see someone come in with an integrity shirt on?
It's Ruben.
Ah, I thought so. Curious, why don't you guys have barcodes doing all this?
To communicate with our machines. So we use them in some cases. Probably our biggest problem is the cost of individual barcode and the labor to label every part.
Okay, see, I was thinking of coming in, I'm sorry. I was only thinking one direction.
Sure. So we'd have to, coming from our supplier, if they're not previously labeled, we'd have to invest in labeling everything.
Okay.
We, in some cases, are, but we haven't distributed that globally. So we're using the system that this team's working on. The interfaces with all of our equipment. So when they get a dispatch sheet, as long as they picked it in the correct order, they should be able to load the parts into the equipment in the same order, and we can avoid labeling everything, avoid that cost.
Oh, sure.
It takes a little more system driven and making sure that we don't mix our parts up. But in the end, so far it's been a pretty good solution other than the management standpoint. That's where our team gets bogged down a lot, especially if we make major changes to the system. As we're doing it manually, if you saw some of the spreadsheets that we were originally working with, we have someone that has to sit down and go through all those parts, rearrange them, reorganize them in whatever order we need.
And that will be taken care
Team
of.
updates, so this is gonna help us out.
What did you find, you said something about you needed to learn languages in order to even get started on this. What languages did you have to do? Do you know?
Sure. So the main ones we're using, like Node.js to connect to the server, was new to us, and also React and Blueprint on the web side, just displaying the information was new to us as well.
Okay, great.
And then a question from Integrity, how, the information that you get to be able to start the project, did you have enough? Do you feel like there's more information or more direction that could have been given to help get the project rolling?
I would say, I mean, more information is never always a bad thing, or usually isn't a bad thing. But I feel like we had enough to get the majority of it done. Maybe a little bit more, just kind of narrow in our field and kind of get going a little bit quicker.
Okay.
Would have been the only thing.
Well, the project that you guys have so far looks like it's right in line with what we were hoping to see, so it's great to see.
So, I imagine there's lots of parts that are going to be in these databases. Is size an issue when thinking about having multiple versions of the database?
For that, each engineer has a different database, and then the supervisors and the developers will have a approval process. So if multiple databases getting changed at the same time, they'll go through it and see the best of it, like kind of like a GitHub. If you have multiple changes, then you edit it.
A couple of questions from the demo. I noticed that you have a save button, and then you have a sync button.
Yep.
So is sync one direction, I'm sorry if I missed that part, but is sync one direction when you pull the changes into your web interface?
Yep.
Or you also push them back at the same time?
No, save pushes them, sync pulls them. And so if you made changes on the front that you didn't want, you could also just sync and it would reset it to the state in the
So sync is
database.
kind of like a revert and pull everything that's whatever, whoever else, other person has done something.
Yep.
Okay, because semantically the kind of sync is usually synchronized both sides, kind of confused me a little bit. How do you deal with conflicts if there are any? So let's say another engineer or another user changed the same field and it does say, you just overwrite it, or is it warning?
Right now, it would just overwrite it, yep. But
Without any warning whatsoever?
yeah, so the plan would be that each person would have their own database, right? So each person, it'd almost be like branching on like a version control system, right? So you're only changing your own data, but then the system developers could go in and, you know, see what all those changes are, and then kind of merge that into like the main one, if that makes
So
sense.
does it work in a kind of like, let's say 5 people did different changes, then I guess an engineer comes in and picks and chooses the changes that are coming in
Right.
into the main database, so to
Right.
speak?
Yeah.
Okay, that's kind of cool. Right. Thanks.
So if you have a batch file for window A, then there's window A prime that's coming up that's just a little bit different. Can you take the batch file, make a couple of changes and edits, and then save it as
Yeah, so
A
that's
prime?
one of our goals is, like the, the profile part map had, a ton of fields. In that case, you might only be changing one of the fields. So with that, we want to be able to like copy and paste the row, down and then edit the one column that's changing.
So when you're syncing, that's with your personal database, right? That's not with the main one.
Correct.
So then how does your personal database get updated with the main database's changes?
Yep, so right now it's when you hit the save button, that's what you've changed gets uploaded to.
To your personal one?
Yeah.
But then how does your personal one get updated with the main one behind it?
Just by syncing, like, kind of like a branch, and then
So that's not implemented yet, but that would be where the system developers would go in, or like the system, or the engineers would be able to like kind of make a pull request, like for their database, and then the developers would have to go in and like ensure that that's the data that they want in the main one, and they would.
and it can be solved by just having a little message every time the system developer update the main database. Just send a message like, "Hey, it's updated. Do the sync," and shouldn't be a hard process to go through.
Okay. It just didn't seem like you had a way from the UI to get the, or update your local data with the main one.
I think I see what he's saying. Do you have an automatic backup of your local databases or something? Because I think I see what you're saying. They don't have a way to save their personal version of the database? Is that what you were thinking?
Like, I guess I was just
Without
thinking,
using something.
if you have 5 pieces of fiberglass on the main database, you get that initial 5, someone makes a change, puts it up to 7, how does your local database get updated to 7? When someone else changed it.
Change your local
Oh,
database?
no, change the main database.
Oh, right. So, I
So
mean,
you're out of
right.
sync with the main.
So right now, it's basically just the local, or like everybody's personal database. There isn't like a main one right now, so to speak. Like that branching and merging system isn't in place yet.
Yep. I'm just wondering what the logic behind it.
Oh, but it's just main database will be updated only by the system developers, and they can just do a little pop-up message like update it, and then it will sync it.
Right. And you'd be able to make like a new one, right? So they'd be able to make a new personal database from the master one too.
Okay.
Yeah, it's something that we plan to do in the future by instancing the databases and then having engineers also have the same merge tools to merge new changes into the current database as well.
Okay.
That's the planned feature. It's just not a focus for this team right now.
We may have to treat it individually. That's a very good point, where we may have to wait until an engineer verifies that they're done with whatever they're trying to do, so we can push, after we've saved their change, push it back up to any individual engineers.
It's a matter of just reversing the pull request process instead of merging from the local database to the main one. It's merging an instance of the main one to the local one. Does that make sense?
Yep, that makes sense.
Okay.
Any other questions?
Just a comment, I think getting that visit to the plant should be up there.
Yeah, we've had a lot of bad runs with like weather lately, so that's why we kept like putting it off. But it looks like it's gonna warm up a little bit here.
Spring break coming up too, so
Yeah.
spring break, integrity windows.
I think this is true.
Try to find some other work for you guys too.
All right, thank you.
Thank you.
Thank you.